Hey folks, I'm Vishal Chaudhary. I'm a software engineer at Nirmata, and I'm a Kyverno maintainer. And today I'll be telling you how you can optimize the cost of running your Kubernetes clusters using Kyverno. So let's start with a brief introduction. Kyverno is a policy as a code tool. We started off with a focus on Kubernetes clusters, but now has moved beyond it, and it also supports any JSON payload. Kyverno has validation, mutation, generation, cleanup, and image verification capability, and we'll be looking into a few of those in this lightning talk. We also have support for Kubernetes native policy reports, where you can create compliance information for all your workloads using Kyverno. We have this testing tool called Kyverno Chainsaw, which can be used to write end-to-end test for all of your Kubernetes workloads. And we also support any JSON payload now. Right. So let's answer the question, why would you want to optimize resources? So the reason for those are twofold. So first is it will help you reduce your cloud bill. So if you have a very large cluster or you have multiple clusters, you can see a significant decrease in the amount of money you spend running your workloads in the cloud. And it will also help you reduce your cloud footprint, which is very important in the current environmental circumstances. There's also a good blog post by Adidas folks where they showcase how they managed to reduce the cost of running their Kubernetes cluster by 50% using Kyverno and other CNCF open source tools. And I will highly recommend you check out that blog after this presentation. Right. So for the challenges, there are 4 major challenges. The first one is there is a conflict of goals between platform owners and application owners, where platform owners would want to minimize the amount of resources given to a workload to maximize efficiency and minimize cost, while any application owner would want to make sure that the amount of resources given is maximum to maximize throughput. And also the workloads are dynamic in nature, so we cannot be 100% sure about how much resources it's going to take, and we don't want to limit it to the point where it starves the workload and causes performance degradation. And also there's a case that the demand for resources fluctuate from time to time. So during peak hours, it can take an order of magnitude more amount of resources than during normal use case. And we'd want to make sure that those cases not get hurt because of this. And also Kubernetes makes it very easy to create misconfigured resources. Like you can easily create a pod that asks for too much resources, and that can cause efficiency issues as well. So you want to address all 4 of these using Kyverno. So to fix this, step 1 is that you should use Kubernetes native vertical pod autoscalers. They will help you solve the problems of fluctuating resource demand and dynamic workloads. And how Kyverno can help you in this case is that you can use a Kyverno generate policies to create vertical pod autoscalers for all of your workloads. So here's an example of a policy that will create a VPA for your deployments and stateful set. And you can create that in recommendation mode. It will take care of all the workload fluctuation demands. Right. Next is for the case of misconfigured resources, you can use Kyverno mutation and validation capabilities. So what you can do is you can set up Kyverno policies to either deny the admission requests that ask for too much resources, or you can just mutate the request to make sure it fits in your criteria of resource consumption. So here's an example of a policy that will validate that the deployment stateful set or daemon set that is created fits in your resource budgets. Right. There's also the case where the resource that you might have created earlier should have been deleted a long time ago, but did not get deleted for some reason. And sometimes what happens is that stops a node from getting shut down, which can also cause cost issues. So to do that, you would want someone who can periodically look at resources like that and then delete them when they are supposed to be deleted. So Kyverno cleanup policies can help you with that. So here's an example of a Kyverno cleanup policy that will look for pod disruption budgets that should have been deleted, and it will delete them periodically. In some cases, you might not even need a policy. Like if you're sure that this resource should have been deleted after X amount of time, you can set up the TTL label on that policy. Like you can set it to 1 day or a few days, and Kyverno will automatically delete them once the TTL expires. So Kyverno can help you optimize the cost of your clusters, and it can also do that while being simple to use. And it has a large library of policies, which will help you fit all of the standard use cases, and they work out of the box. And Kyverno also does not require any coding experience. So if you liked what we talked about, or you would want to talk to us more about this, you can find us at Exhibition Hall 1B at table number 4 in the second half today. And we also have a few more talks related to Kyverno coming today and tomorrow, and we would love to see you there. There's also the link to our GitHub organization. You can find us at github.com/Kyverno, and there's a QR code for that as well. Thank you so much for attending the talk.